Good morning, student. Uh, we are studying the chapter aldehyde and ketone. Up to now, we have finished the introductory part of aldehyde and ketone. Then we have discussed about the properties of aldehyde and ketone, how it will be changed according to the molecular weight and all. Then we have seen the nature of carbonyl. So how it is getting a partial positive and partial negative charge. Then we have seen the synthesis of aldehyde by different methods, and then we move towards the synthesis of ketone or preparation method of the ketone. Then in earlier lecture we have seen the nucleophilic addition, how it is happening to the carbonyl carbon. So uh, we have discussed earlier the benzoin condensation. So one of the reaction, it is a nucleophilic addition reaction. Then we have seen the aldol condensation. So in this aldol condensation, the alpha carbon. So I have discussed earlier what is mean by alpha carbon. This the carbon near to the carbonyl group is known as alpha carbon, and the hydrogen attached to this alpha carbon is known as the alpha hydrogen atom. So these two are the alpha hydrogen atoms. So alpha carbon atom of one aldehyde or ketone molecule gets attached to the carbonyl carbon of the another aldehyde and ketone molecule with the migration of alpha hydrogen atom to oxygen atom. So this mechanism we have seen. So I just wanted to show, like, as a repetition of this lecture, earlier lecture. So the aldol condensation is the name to from the intermediate which we have got in this reaction. It is a aldol. So it is easy to remember. Then this reaction take place in between two aldehyde, identical aldehyde or different aldehyde, and it is also taking place in with these two identical ketone or different ketone, and it is also take place in between two aldehydes and two ketones. So then we have seen the mechanism of the reaction. We have seen up to now. So we will move towards today's lecture. So in cross aldol condensation, cross means in between two different aldehyde. So what happened? Two different aldehyde we are taking. This, hence it is known as a cross aldol. So both aldehyde have need a alpha hydrogen atom and forms carb anions, and both act as a carbanion acceptors. So what is meant by carbanion? If we are getting the negative charge on carbon, so it is known as carbanion. So both aldehyde have alpha hydrogen atom. So this is the basic requirement of aldehyde as we have seen earlier. And then this first step of the reaction is formation of carbanion. So this base is get dissociate uh, into respected conjugated acid and base, and this OH hydroxyl group act as a nucleophile which abstract a proton, and then this the lone pair of electron is shifted towards the carbon, and this negative charge. So this carb anion is more stable due to the conjugation between this carbonyl carbon. So this is the conjugated pair of this lone pair of electron is shifted toward this, and then the 5 electron of a carbonyl sharing bond is shifted to the oxygen. So here in this case the water molecule is removed. This reaction is also known as a Claisen-Schmidt reaction. So the cross aldol condensation, if in MCQ if you ask, the cross aldol condensation is also known as the Claisen-Schmidt reaction. So further, and as we have seen how the aldehyde get from the carbanion and it gets stabilized. and then again, so these two structure can exist simultaneously. So this carbon ion then attack on the carbonyl carbon, because carbonyl carbon is the positively charged. Here in this case, uh, this carbonyl carbon get attacked mm, by these carbon ion, and then the pi electron is shifted towards the oxygen atom, and then if water molecule will be there, so this uh, oxygen, nucleophilic oxygen, it abstract the proton from the surrounding environment. So after the proton acceptance, so it is get converted into the aldol product. So this aldol reaction, aldol product obtained was got dehydrated and form the cinnamic aldehyde. So here in this case, there is a removal of again water molecule, and due to this we are getting a double bond here. So this double bond is very stable due to the hyperconjugation, conjugation between the benzene ring and this functionality. So due to this intermediate, this reaction is got named aldol, and then the final product form is alpha beta unsaturated aldehyde. So what is happening in cross aldol or Clemmensen-Schmidt reaction? Two different aldehyde. Here we have taken the aliphatic aldehyde and then aromatic aldehyde, and then aliphatic aldehyde form the carbon ion, which was uh, in, act as a nucleophile, which is attack on the benzaldehyde, and then we have got the intermediate. After the acid protonation of this intermediate form the aldol intermediate, and then aldol after dehydration got the cinnamaldehyde. We will see next the aldol condensation between two identical or different ketones. So here we have taken this identical ketone, in which how it is happening we will see. Aldol condensation between two identical ketone is not very successful reaction. So the equilibrium lies far over the left, and then this is because the carbonyl carbon of ketone is less positively charged. Here the cross aldol of the ketone is less favorable and gives low yield. Here if you'll see for this example, so only 2% of this product we have obtained, the aldol product. So in this reaction, so this aldol condensation between the ketone is less favorable reaction. Hence, this is more likely to be uh, happening in the aldehyde. So here the mechanism of the reaction is the same. However, it is possible to prepare the acetone alcohol, it is aldol, in the reasonable good yield by boiling the acetone with the solid BaOH2, barium hydroxide, is special device apparatus. So this is the best way. Here they have used, earlier we have used the sodium hydroxide. So here the OH from this base got abstract the proton, similarly from the uh, carbanion, which was stabilized by resonance, and then this carbanion got attacked to the another hydroxyl carbonyl carbon, and then formed the alkoxide intermediate, which was further protonated and formed the diacetyl alcohol, which is aldol. And this the aldol formed product was then again the dehydration uh, by using this base form the final product, which is alpha beta unsaturated ketone. It is here in this case is mesithyl oxide. So this is the aldol reaction between the two ketones. This reaction is not so much favorable. So what we have seen, The aldol reaction is most favorable in aldehyde, but it is not favorable in ketone due to the equilibrium shift towards the left hand side. And the reaction between the two aldehyde and form the alpha beta unsaturated aldehyde in ketone is forming the alpha beta unsaturated ketone. And then cross aldol is also called Claisen-Schmidt reaction. So these points you have to remember, and you have to remember the mechanism of the reaction. So it is very simple, and you have to practice it so you can remember these things. So next we will see the cross aldol condensation between aldehyde and ketone. So we will see these things in the next lecture. And for up to now, whatever the things happen, we have learned in aldehyde and ketone. So this 20 mark test we have uploaded in your Google form. So you have to attend the same. And now tomorrow we will continue the lecture. Thank you.